Okay, example 2 is another type of subscripted variable problem. This one here relates to uniform motion problems. Johnny was driving a car at 60 miles an hour before Susie left to catch him. 5 hours before Susie left to catch him. If Susie drives 80 miles an hour, how long does it take her to catch Johnny? I think I said Johnny to begin with. Anyway, we'll find out. Watch the video back to see if I messed up. Anyway. This case, this is a technique for solving these uniform motion problems. The technique I've given you is use of that graphic organizer with all the charts and everything. But it's still good to be able to handle a problem like this just for your basic algebra abilities. When you see these subscripted variables, R sub m, R sub w. So the letter R has 2 subscripts, and T sub m, T sub w, T has 2 subscripts. We can't just use the subscripts for the variables, because if I try to use m for the subscript for R, or for R sub m, well, I would also probably use m for T, and all of a sudden I got these 2 different things being represented by the same letter. So there's no way to make the subscripted variables go away in this problem. The key, what lets you know that's this kind of problem, 1, 2, 3, 4 equations. You see 4 equations, subscripts have to stay. You see 2 equations, you can probably get rid of the subscripts. What we're looking for in a 4-variable subscripted problem is we're looking for the equation that contains all the variables. Okay, that one up top contains all the variables. Usually it's the first one. Okay, later on this year we're going to revisit this topic. And they're going to have it, it's going to be arranged a little differently. There's not going to be a main equation that contains everything. For now, we'll have that main equation that contains everything. The remaining equations, we're looking for a specific structure in these equations. If it has that structure, we're in good shape. If it doesn't, we have to modify it so it has that structure. What I'm looking for specifically is one of the things up in the top equation equals something else. It doesn't matter if it equals something else as a number or an algebraic expression, just that it equals something else. So R sub m has a different object, so R sub m can be substituted. R sub w is equal to something, so R sub w can be substituted. The bottom equation doesn't say T sub m equals or T sub w equals, so that one's not good. Okay, so we need to modify this one. I either need to move this guy or that guy over to the right. It doesn't matter which one. Which one do you want to move?
T sub w.
W. Okay, so we want to move the T sub w over to the right-hand side. If I do that, that leaves me with T sub m on the left equals 5 minus T sub w on the right. And again, T sub m, something up here equals something else. The 3 things I have underlined in the main equation, R sub m, T sub m, and R sub w have a different thing that represents them. So at this point, I want to substitute all 3 things in at once. So I've got my main equation here. The very first thing listed in the main equation is R sub m, and R sub m is equal to 40, so I'm going to put a 40 down. R sub m is being multiplied by T sub m that has a different version. So I want to change T sub m into 5 minus T sub w. When I substitute, if I substitute more than one term, for one term I have to use parentheses. So this is R sub m being multiplied by T sub m. Now this is R sub m's substitution, 40, being multiplied by T sub m's substitution, 5 minus T sub w. Again, this is multiple terms, so parentheses are required in that substitution. Then there's a plus sign. So I put a plus sign. Run out of room. Uh-oh. That did not work as planned. Alright. Next thing I see, I've got an R sub w. Right? R sub w equals something else, 60. The next thing I run into is T sub w. Not one thing down here says T sub w equals, right? There's a T sub w down here, but it's not T sub w equals something else, right? So I don't want to mess with that one. I'm going to keep it T sub w. So when I substitute, I've got 3 equations, 1, 2, 3 equations here. All 3 of those equations represent something else. Substitute those 3 things. The one thing that doesn't have that letter equals something else, it's going to stay that letter. And then equals 260. Okay, the key to this problem and getting it right is that you do that step correctly. Okay, if you do that step correctly, your algebra skills from this point should be pretty basic skills involved, and you guys should be able to handle it pretty easily. So, what I got to do now is solve. Simplifying first, 40 times 5 and 40 times T sub w makes 200 minus 40 T sub w plus 60 T sub w is equal to 260. Both of these have T sub w, so I'm going to keep them on the left. I'm going to take the 200 over to the right. It's positive 200, moves over as a negative 200. These are opposite signed objects, so I subtract. It's positive because 60 is bigger. These are opposite signs objects, so I subtract, and it's positive because 260 is bigger. And then we simply divide both sides by 20. We get t sub w is equal to 3. Now when it says solve a system of equations, there's 4 variables in this, right? There's r sub m, there's t sub m, there's r sub w, and there's t sub w. R sub m and r sub w are already known. So even though those are variables, we have known values for them. The two things we don't know are the times, so the t sub m and t sub w. We just figured out what t sub w is equal to, which is 3. The other thing I need to know is what t sub m equals, so 5 minus 3, because that's what we figured out t sub w to be. Once, just another basic substitution there. So that gives me t sub m is equal to 2. Occasionally when you do these problems, the answers come out as decimals or fractions. I prefer fractions to decimals, but just know that they do pop up sometimes. Let it happen if it happens. Make sure you do this step properly where you substitute all your stuff in. If you do that step properly, everybody's algebra skills to this point should be good enough to get the right answer. Be confident in the right answer. If you get something you're unconfident, like I don't think t sub w should equal 897,000. Probably not. So then maybe you did something wrong up here. All right. So because again, going from here to here, you guys mastered that last year, and you practiced again this year well enough that based on your homework, you guys do that well. So if you're getting some weird answer down here, probably you substituted in something wrong. That's more likely where you're messed up. Maybe if you got parentheses, you only multiplied this and didn't multiply that. Something like that would happen. So be careful that you do that step properly. Everything from that point forward should be pretty straightforward.